Hi and welcome to this course. My name is Maximilian Schwarzmüller and I will be your instructor in this course. Now this course, of course, is about Docker and Kubernetes, two amazing technologies which make managing and deploying and also developing more complex applications way easier. You're going to learn what exactly Docker is and what it's about. It's related to something called containers, and I'm also going to explain that over the next lectures. And throughout this entire course, you are going to learn how to work with Docker and containers, which different commands to run, what you can do with Docker, how to solve different problems with Docker, how to use it locally on your machine, on simple projects and more complex projects, how to deploy projects and applications with Docker. And we're thereafter going to dive into Kubernetes too. And you're going to learn what the connection is between these two things and why you might need Kubernetes in addition to Docker. And we're going to learn what Kubernetes is and which things make up Kubernetes. And we're going to learn how to use Kubernetes on our projects and how we can deploy projects with help of Kubernetes and what the advantages of this might be. There's lots of content in this course, and we're going to dive into these different concepts in theory, yes, but most importantly, with a lot of small demos and examples. We're not going to write any code. This is not a programming course where I want to teach you a specific language. Instead, I will provide small examples to you and will then use these examples to dive into different problems we might face and how Docker helps us solve these problems. That's the idea behind this course, and that's what we're going to do throughout this course. And therefore, we'll start at zero. No prior Docker knowledge is required. No prior Kubernetes knowledge is required either. And we're going to dive into the different problems we can solve and the different features Docker offers us step by step throughout this course. And therefore, by the end of this course, you will feel confident using Docker and Kubernetes in your next project. You will know what it is, and you're ready to dive deeper into it, dive into advanced scenarios, anything you might want to do. So therefore, let's not waste any time, and let's instead start with the most important question. What exactly is Docker, and why might we want to use it? What's its advantage? So let's start with the most important question right away. What exactly is Docker? Well, Docker, in the end, is a container technology. It's a tool for creating and managing containers. Okay, so that clearly is a nice sentence, but what exactly does it mean? What's a container in software development, and why might we want to use it? Well, a container in software development is a standardized unit of software, which basically means it's a package of code and that's important, the dependencies and tools required to run that code. So for example, if you're building a Node.js application, Node.js is a JavaScript runtime which could be used to execute JavaScript code on a server. If you had such an application with a container built with Docker, you could have your application source code in that container, as well as the Node.js runtime and any other tools that might be needed to run that code. And the advantage is that the same container with the same Node.js code and the same Node.js tool, so the same Node.js runtime with always the same version, will always, and that's the key thing, will always give you the exact same behavior and result. There are no surprises because it's all baked into the container. It's always the same. But maybe it's even easier to understand this concept if we take a step back. Think about a picnic basket. A picnic basket contains everything you need to have, well, a picnic, dinner in the park, something like this. It contains the food and it contains the dishes which you need. And therefore, you can take that basket and take it everywhere where you want to have that picnic and you're ready to go. You have it all in that basket. You can also share that basket with a friend and that friend can have that same picnic you would have had otherwise. There are no surprises. You have the dishes and the food. You don't have to look for dishes at the place where you want to eat. And maybe then you have soup with you. Might be strange with a picnic, but whatever. And then you don't have the dishes for eating soup. If you pack your own picnic basket, it's all in there. And that's the idea behind a picnic basket. It's the same idea behind containers and Docker, which is just a tool for creating and managing these containers. Now, the term container might be strange at first, because if you hear about a container, you might think about something like this. At least that is what I know as a container. But actually, it's not a bad comparison. This is a container we would load onto ships or trucks to move goods around. Well, and it's the same idea as with Docker containers still. We have standardized containers here like this, and we can fit various goods into these containers. But they are then self-contained and isolated. The goods in one container don't get mixed with goods from another container. If you need something like cooling, it can be built into the container, and therefore the container works standalone. And it can be put onto any ship or any truck which is able to handle containers. And that's exactly the same with Docker containers. We have our units of software, our packages with code and with the dependencies to run this code, and we can then take it anywhere where Docker runs. And we will then be able to run exactly the same application with the same environment wherever that is. We don't need to worry about installing any extra tools in that place where we want to run our application, because it's all in the container. That is what containers are, and that is what Docker is about, because Docker is just the tool for building these containers. Now, the good thing is that support for containers is built into modern operating systems, or at least there it's easy. So we now know what containers are and that Docker helps us create these containers. I also already outlined some advantages, but still you might wonder, why exactly do we need containers in software development? Maybe the example made sense for a picnic basket, and to some extent it makes sense for a software development, but is it really that important and useful? Yes, it is. We should just ask ourselves one simple question. Why would we want independent, standardized application packages in software development? Well, for one very good and typical example, and one of the main use cases of Docker, I would say, we of course often have different development and production environments. And here's a simple example. Let's say you created a Node.js application and you wrote some code there which requires Node.js version 14.3 to run successfully. And this is not some made-up example. The example you see here is Node.js code which uses a feature called top-level await. Now, you don't need to know Node.js to follow along with this course. For the moment, it's enough to know that this is a feature which would not work in older versions of Node.js. We need Node.js 14.3 or higher to execute this code successfully. The problem is that we might have that version installed on our local environment, on our development environment, on our local machine. But if we then take this application and we deploy it onto some remote machine, onto a server where it should be hosted so that the entire world can reach it, then on that remote machine, we might have an older version of Node.js installed, maybe 14.1 or 12 or 8, whatever. And all of a sudden, the code which worked locally on our machine doesn't work there anymore. And depending on what's going wrong, it can take quite some time to figure out what the problem was. So having the same, and with that I really mean the exact same, development environment as we have it in production can be worth a lot. And that is something where Docker and containers can help you. You can lock a specific node version into your Docker container and therefore ensure that your code is always executed with that exact version. And all of a sudden, that potential problem is gone and can't occur anymore, because your application runs in that container, which brings its own Node.js version. So that's one example. Kind of related to that would be another example: different development environments within a team or company. Let's say we're in a big team. I'm working there and you are working there. And now we're working on the same project. For example, that same Node.js application again. Now, because you haven't worked with Node for some time, or because you didn't need to update, you still have an older version of Node.js installed on your system. And I have the latest version. So I wrote this code with top level await, and when I share the code with you, it doesn't work for you. Now, obviously, you might say, updating Node.js is no problem. I can easily update it on my system and we're on the same page again. Yes, but for one, it's just one example. There could be more complex projects with more complex dependencies which you need to manage and install. And in addition, even in that one example, it's still annoying that we're not able to work on the same code base together and we have some guarantee that it will always work and that we always use the same environment. We want that reproducibility in software development, and therefore even here, if we're not deploying it at the moment, having that locked in environment with everything the code needs in the container can be worth a lot. And now last but not least, even if you're working on your own, then still Docker and containers could be very useful. Because if you have multiple projects on which you're working, then you might have clashing versions. Let's say one project uses Python version 2 still for whatever reason, another project uses the latest version of Python. The same maybe with Node.js or PHP or whatever kinds of projects. There you would have clashing versions, and that means that whenever you switch from project A to project B, you have to uninstall the wrong version and install the right version. For example, if one project needs Node version 12, the other project needs Node version 14. If you switch projects, you have to uninstall version 14, install version 12 instead, and vice versa. So switching between projects becomes a big hassle and is no fun at all. And that again is something where Docker and containers can help us. We lock our versions into the containers, and every project has its own container. And therefore, if we then switch projects, it'll just work like that. We don't need to uninstall and reinstall anything because it's all in the container, not globally on our host machine. And therefore, switching projects becomes as easy as launching a different container. And these are all things we're going to see throughout this course, and you're going to learn everything you need to solve these problems throughout the course. And that's why we might want to consider working with containers and why Docker is a quite helpful tool. So now we know what Docker is and what containers are and why we might want to use it. We will learn what exactly Kubernetes is a little bit later in the course, by the way. But let's stick at the basics for now, containers and Docker. The problems solved by Docker and containers make sense, hopefully, and it makes sense that we might be looking for a solution like Docker and containers. But if you've been in the software development area for some time, you might also think to yourselves, why Docker and why containers? Isn't that a problem? So that reproducible environment thing, isn't that a problem which we can solve with virtual machines? So machines running on our machines, virtual machines with virtual operating systems encapsulated in their own shell, independent from our host operating system. Isn't that a solution? Well, kind of. With virtual machines, we have our host operating system, Windows or Mac OS or Linux, and then on top of that, we install the virtual machine. So a computer inside of our computer, so to say. This virtual machine has its own operating system, the virtual operating system which runs inside of that virtual machine. Let's say Linux. Then in this virtual machine, since it is like a computer, it's just virtually emulated, you could say, but inside of that virtual machine, we can then install extra tools. We can install whatever we want in there because it is just another machine, even though it just exists virtually. But we can install all the libraries, dependencies, and tools which we need, and then also move our source code there. And hence, since it's an encapsulated virtual machine with everything our program needs and all the tools being installed there, we kind of have the same result as with Docker and containers. We have an encapsulated environment where everything is locked in. And we could then have multiple such environments for different projects, or we could share our virtual machine configuration with a colleague to ensure that we're working in the same environment. Well, this works, but there are a couple of problems. One of the biggest problems is the virtual operating system and in general the overhead we have with multiple virtual machines. Every virtual machine is really like a standalone computer, a standalone machine running on top of our machine. And therefore, if we have multiple such machines especially, we have a lot of wasted space and resources, because every time a brand new computer has to be set up inside of our machine, and that of course eats up memory, CPU, and of course also space on our hard drive. And that really can become a problem if you have more and more virtual machines on your system, because you have a lot of things which are always the same and still duplicated, especially the operating system. You might be using Linux in all your virtual machines, and still it's installed separately in every machine. And that of course wastes a lot of space. In addition, you might have a lot of other tools installed in every virtual machine which your application doesn't need directly, but which still are set up as a default. And that can be a problem. So to sum it up, virtual machines have a couple of pros and cons. They do allow us to create separated environments, and we can have environment-specific configurations in them, and we can share and reproduce everything reliably, but we do have this redundant duplication, that wasted space. Performance can be bad since we have an extra machine running on top of our host system, and especially if we have multiple such machines, performance can really degrade. And in addition, even though it is reproducible and shareable, that also can be tricky, because you still have to set up that virtual machine on every system where you want it, and you have to then configure it in exactly the same way. There is no single config file you can necessarily share. If you want to deploy your application, so from development to production, you also have to ensure that you configure your production machine in the same way as your virtual machine. Alternatively, you run your virtual machine on your production machine, but that wasted performance, that's something you might not want to do in production. So it solves the problem, but not in a perfect way. And you might guess that's why we have Docker and containers. And actually, it's really important to understand that containers is the key concept here. Docker is just the de facto standard tool for creating and managing them. So why does Docker help us with that? How do containers solve that problem in a better way than virtual machines do? With containers, we still have our host operating system, Windows, macOS, Linux, whatever it is, but then we don't install a couple of machines in the machine. Instead, we utilize built-in container support, which our operating system has, or emulated container support, something Docker will take care about that this works. And then we run a tool called the Docker engine on top of that. And that will all be set up by Docker when we install it, by the way. And then, based on that Docker engine, which now runs on our system, which is just one tool, one lightweight small tool being installed there, we can spin up containers. And these containers contain our code and the crucial tools and runtimes our code needs, like Node.js, for example, but they don't contain a bloated operating system, tons of extra tools, or anything like that. They might have a small operating system layer inside of the container, but even that will be a very lightweight version of an operating system, much smaller than anything you would install in a virtual machine. And you're going to see how containers work exactly and how you create them throughout this course, of course. Now, the other great thing about containers is that you can configure and describe them with a configuration file, and you can then share that file with others so that they can recreate the container, or you can also build the container into something which is called an image, which you need to do anyways, and then you can share that image with others to ensure that everyone's able to launch that same container which you have on your system on their systems. And obviously, we're going to dive in detail into images and containers throughout this course. So you are going to learn all about that step by step. So if we compare containers to virtual machines, we have a couple of advantages on the container side. They have a low impact on our operating system and machine, they're very fast, and they use minimal disk space. Sharing, rebuilding, and distributing them is very, very easy because we have these images and these configuration files. And we still have encapsulated apps and environments with everything our app needs, but nothing more, which is perfect, which is exactly what we want. Virtual machines, on the other hand, have that bigger impact on the operating system. They tend to be slower, and they also tend to eat up more of our disk space. In addition, as I said, sharing, rebuilding, and distribution, that all can be done, but also may be trickier than with containers and Dockers. Still, of course, we encapsulate our environments, but we don't just encapsulate our app and what it needs to run, but entire computers. It's like having a totally separate machine, which in rare examples or in rare use cases could be an advantage, but often it's just a bloated thing which you don't necessarily need. So by now we have a first good idea of what Docker is, what containers are, and why it might be interesting to work with these things. Now, of course, to work with Docker, we need to install it. So in order to create these containers and work with them, we need to install Docker. And when it comes to installing Docker, the exact steps depend on the operating system you're using and then also on certain system requirements which you need to meet. And for that, it's best if you visit docker.com. There, if you go to Developers, Docs, and then to download and install, you can choose your operating system and you will find the system requirements there. And for example, you see for Mac, you need a hardware newer than 2010, and a Mac OS version which is 10.14 or newer, at least at the point of time I'm recording this. For Windows, you also got certain requirements. For example, you need Windows 10, Pro, Enterprise, Education, or Home. And for Linux, you actually don't have any specific requirements because there you'll be able to use Docker basically everywhere. Now I will come back to the different platforms and the exact installation steps in a second. But for the moment, you should just check whether you meet these requirements or not. For macOS, if the requirements are met, you can install a tool named Docker Desktop, which is the recommended tool you should use when working with Docker. If the requirements are not met, then you can install an alternative tool called Docker Toolbox. Docker Desktop is the recommended tool, but if there is no way of getting that to run, use Docker Toolbox instead. I will show you both, by the way. I will show you the setup steps for both tools over the next lectures. For Windows, it's the same. If the requirements are not met, you should install Docker Toolbox. If they are met, you should use Docker Desktop, just as on macOS. And for Linux, it'll be a bit easier. There you have no Docker Toolbox or Docker Desktop tool. Instead, Linux natively supports the Docker engine, and therefore you can directly install that engine on Linux. Docker Toolbox and Docker Desktop are basically just tools that bring Docker to life on non-Linux operating systems, you could say, because the Linux operating system natively supports containers and the technology Docker uses, you could say. So therefore, for Linux, if you want to install Docker, you can use the attached resources, which in the end also just guide you through some setup steps for Linux, where you install Docker just like this on Linux. It'll be really straightforward. And once you're done with that, you will be able to run the Docker command. Now for macOS and Windows, as I mentioned and explained, you can't install Docker just like that. Instead, you need the recommended Docker desktop tool, or, if not supported, the older Docker toolbox tool. And now over the next lectures, I will show you installation on both macOS and Windows, and I will show both Docker desktop and Docker toolbox. We start with macOS in the next lecture, Windows thereafter, and thereafter Docker Toolbox for both operating systems. Therefore, choose the lecture which makes sense for you, so which matches your operating system and your answer to the question whether you meet the requirements I showed you a couple of minutes ago or not. And thereafter, we'll all have the same setup where you can use Docker. So no matter how you install it, in the end, you will be able to use Docker. And in this course, I will use macOS for my videos, but what I show you there and what I teach you there applies in the same way on Windows. You will execute the exact same commands on Windows. So with that, let's dive into the different installation steps in the next course lecture.